Honestly, I feel like I'm just banging the gong on this again and again and again, saying the same thing, but it's so important, and it's such a huge opportunity that I just need to do it because I gotta let the people know. Hey there, and welcome to my channel, The Paper Bag Investor. Today's video, I want to look at an article in detail that talks about Tesla's unassailable full self-driving lead, and how I agree with this article, and why I think it really paints the picture that Tesla could easily be a 10x, 15x plus company in the next 10 years. Really important to understand this stuff, really important to consider this stuff carefully because the implications are huge, could be huge for your portfolio. So let's get into it. And before I go any further, absolutely clear, not a personal financial advisor, just a guy with a paper bag on his head who loves investing, loves thinking about the future. If you love investing, you love thinking about the future, I encourage you to subscribe if you get value out of this video. How Tesla's computer vision approach to autonomous driving built an unassailable lead in full self-driving. Unassailable meaning unable to be attacked, questioned, or defeated. So let's go through this in detail. Dheepan and Ivan, both machine learning engineers. I know Dheepan works at Amazon, but they've worked at other Fortune 500 companies doing machine learning. They put out this article today, and they talked about this lead that Tesla has in full self-driving. And it's a really big deal. It's a really big deal because if you look at even, for example, ARK Invest Tesla model, their recent model of $3,000 a share for Tesla by 2025, 50% of that model comes down to full self-driving, is basically driving that or contributing to that model. And my own model, when I've modeled Tesla out 5 years, 10 years, the biggest component by far for me is, again, full self-driving. It's extremely important, and essentially I think that's going to be Tesla's model. They're going to sell, sure, the best vehicles in the world, electric vehicles, and the very best electric vehicles, but even if they can sell those vehicles at cost or even a small loss, they're going to make the lion's share of their income, most of their income, in my opinion, from their software. Okay, and I'm going to show you kind of a quick breakdown, my own breakdown on their software valuation of robo-taxis, or full self-driving robo-taxis. So this is from another video I did a number of months ago. I've tweaked it a little bit since then, but if you assume from 2020 to 2030, Tesla grew at a 40% compound annual growth rate. They'd be making about in vehicle unit sales. So by 2030, it actually puts you at about 14.5 million vehicles sold in 2030. But if you sum up all those vehicles that are scaling up from 2020 to 2030, you have about 50 million vehicles. And now if we assume that 20% are used as robo-taxis full-time, that gives you a 10 million robo-taxi fleet. Of course, some of these robo-taxis is going to be like a curve, right? Some are going to be used a little bit of the time. Some are going to be used a lot of the time. But overall, we're going to say it's sort of an average that 20% would be full-time robo-taxis. For each robo-taxi, if we look at each one, we're going to assume they could do about 100,000 miles of driving in a year, which is 50,000 billable miles a year. And if it's $1.25 a mile roughly, of course this could be even higher to start. This could probably be dynamically priced, but we're going to assume an average of $1.25 a mile. This should also descend over time. But $1.25 a mile, on average, you have about 62,000 in revenue. And from ARK Invest, some other models they've done, they've estimated about 25 cents a mile in operating costs for electric vehicle. Of course, the more you drive an electric vehicle, like 100,000 miles a year, the cheaper electric vehicles get because their consumption costs are much lower than gasoline cars. So you get cheaper and cheaper the more you drive, and you get about 25,000 in expenses. Again, 25 cents times by 100,000, and this is your revenue, $1.25 times by your 50,000. Subtract these two numbers, you get a net profit of 37,000, and we're just going to assume 22,000 goes to the vehicle owner, 15,000 to Tesla. Of course, this ratio could really teeter-totter. Depends on if they need more vehicle, owners. to be managing the fleets, managing them actively. Well, either Tesla could take that on themselves, or they make this number bigger to make it more enticing to vehicle owners to make them full self-driving vehicles. So maybe you make $2,000 a month off your Tesla by running it around. If you make 24,000 roughly, you kind of average that out. But yeah, in this scenario, we have 22,000 going there, 15,000 to Tesla, and robotaxi. So the operating profit of the robotaxis would be about $150 billion, because you have 10 million robotaxi times by 15,000 each. That gives you $150 billion in that year. And now assume 21% tax rate gives a net profit of $119 billion. This is base, operating profit. There's really no additional cost. We're going to assume basically all this money just goes straight to the bottom line. Take off your taxes, $119 billion. We're going to say a PE ratio to this amount of 50 to give a net profit. To the net profit gives about a $6 trillion market cap from the robotaxi side. I'm not going to do this in this video, but in that other video, and I could do in future videos as well, I'm estimating a vehicle side market cap. I'm still kind of estimating that they will be making money from their vehicles, and that's around 2.7 trillion by 2030 when they're selling 14.5 million units a year or more. 2.7 trillion there, but your 6 trillion on the robotaxi gives you about 8.7 trillion market cap in 2030. 8.7 trillion, and it's about a $586 billion company today. Gives you about a 15x increase over 10 years from today's stock price, which 15x over 10 years is a phenomenal return, about 31% compound annual growth rate for the next 10 years. So, and again, that's about what I've done in the last 12 years in my investing so far. We've been in kind of a bull market since then. So I hope I can continue to hit that with my Tesla investment, and this is accurate. I actually think this is fairly conservative because I think the biggest piece, the highest, most conservative part of this would be the PE of 50. I think this could be like PE of 100, PE of 200 at that time, because really there's only going to be I'm only counting 10 million full-time robotaxis, but there's there's about 1.5 billion vehicles on the planet. So 1.5 billion vehicles on the planet, and there's only 10 million robotaxis. It's like a drop in the bucket compared to how many vehicles are out there. And so the demand for robotaxis is going to be much, much, much bigger than the actual supply of robotaxis that can meet that demand. So that's why I think this 50 could be much higher, and this is actually a conservative 31%. That's why this matters. That's why this is so important. Now we're going to dive back into this article and jump back in here and see the details of what these guys are talking about, of why they think Tesla has this dominant lead over everybody else. So let's jump back in. And there's some other people that don't agree with these guys, wouldn't agree with my own model that sees Tesla really dominating this space and making a ton of massive amounts from it. Even in my model, even if other people, automakers, were to somehow solve autonomy, or maybe autonomy in small geo-fenced areas, I don't think it would have the same effect, because I still think the demand for robotaxis would be much greater than any supply could be given. So these numbers are still realistic, and would just mean you'd have multiple huge winners, not just one massive winner like Tesla that could grow even bigger than this 8 trillion. Okay, so this guy, Gary Black, somebody I really enjoy his sort of short to medium term Tesla analysis on Twitter is in my opinion one of the best. But he's definitely a full self-driving naysayer, which actually is encouraging to me. He doesn't include it in his model. When you do read his tweets, you kind of know he's not even including full self-driving as a very big effect. But I think he's not the guy to listen to. He's not a data scientist. No offense to Gary Black. He's not an engineer. He's a long-term stock investor. So I wouldn't listen to him about the details of full self-driving personally. Okay. So back to the article, they say these strongly disagree with this kind of view that it's going to be this easy, once somebody releases full self-driving, other people are just going to catch up and copy the software. That's kind of what Gary Black was suggesting. But they think Tesla has basically already won autonomy by taking this computer vision approach. And the reason it's so much better than any other strategy that's being employed right now is because it can be generalized, it's low cost, and it's highly scalable. So, and they make this really great point. They say similarly, current legacy automakers are trying to reverse engineer and copy Tesla's over-the-air updates. Essentially, Tesla's, as you probably know, you can just get over-the-air updates, software updates, connect to your home's Wi-Fi, and you can make any software adjustments or updates they need to. Really obvious thing to build into the system and framework of a vehicle, but you know, there's still most legacy automakers still completely struggling with something that simple. So to actually try and copy and implement, you know, a autonomous driving that Tesla has they're suggesting orders of magnitude more challenging, and as a result, extremely unlikely. And I completely agree. With that. Okay. So Tesla's approach to full self-driving, how is it different? So there's other guys like Waymo, Cruise, Baidu in China. And if, for example, there's full self-driving happening. If you go to Chandler, Arizona, Waymo and Tesla cars can both take passengers from point A to point B. There are some examples of this on the internet. If you look up Waymo, of them taking passengers around Chandler, you could go travel there and you could ride in one of their autonomous vehicles. But the problem is Waymo is using LIDAR, and it's a very their whole system it basically can only function in one small geo-fenced, highly mapped out area. And so if you try and leave that area, Teslas can continue to drive because they can drive in a generalized sense, but they're going to completely break down. That's how their approach is very different. Okay, so, and there's basically, as they point out in the article here, there's 3 ways you can try and solve autonomous driving. So there's city infrastructure modernization with sensors. So basically you adapt the city to meet the car. Very difficult to do. It'd probably be constant monitoring of the sensors, constant maintenance or repair of sensors. They're saying this has been tried in China, which kind of makes sense when you have a communist government that can really just slam down and just make a decision and you go with that decision. But very difficult to do. Very difficult to scale. LIDAR is the next approach. You're basically using lasers to scan an environment, and you build high definition maps that the car is able to follow. And this is used by Waymo, as we mentioned earlier, that's operating in Arizona there, and then General Motors Cruise and Intel's Mobileye. The Mobileye actually has a combination of computer vision and LIDAR, but we'll get to a little more detail on them later. And then there's computer vision, and this is what Tesla is doing. And also Comma AI, which is a much smaller company that's is a third-party company to other. You could put it into your vehicle, and a few other smaller players. Okay. So why is computer vision superior to LIDAR? So LIDAR stands for light detection and ranging, and basically laser waves to map distance between objects and build high definition maps of the area. And they give this good example or kind of illustration of 2 students, and this is your LIDAR versus your computer vision student. So your LIDAR student is basically cramming and memorizing the content. So they're just basically creating a memorized copy of the content for an exam, for example. And the other student is really trying to actually understand and learn the material so they can they actually know what it means and understand it. And they're making the point that, like, if the teacher swapped some of the questions around on that test, this theoretical exam, the LIDAR student would completely fail. Their whole approach would completely break down. Maybe they'd memorized the multiple choice answers to a 100-question exam in the exact order they go in, but they didn't understand actually any of the answers or questions. And then the teacher scrambled the order of the questions, and they're basically hooped. It quickly breaks down if anything's out of alignment. But the full self-driving is this generalized approach that actually seeks to understand the environment and what they're driving in. I'd like to describe it as the LIDAR is really just lasers. The full self-driving or computer visions and an augmented neural network is trying to actually build understanding of the world around it. Okay, so LIDAR, it goes into a little more detail here on LIDAR. LIDAR is highly accurate and combined with predefined maps can create autonomous driving vehicles. However, there are major drawbacks to this approach. The cost of equipment, so it is a lot more, is a major cost of the vehicle, so it's difficult to scale even a testing fleet of LIDAR vehicles, though this is the LIDAR is coming down in price. So maybe that this critique of LIDAR is becoming less relevant, but it is still a major critique. Also, LIDAR is the biggest one. I'd say the the biggest critique for me for LiDAR is it's not scalable, it's not adaptable. It relies on this pre-mapping every area, and it makes it really, really brittle. Like, as we mentioned before, kind of like the example of the test and the student just memorizing the answers. If anything has changed in any way, you basically need to update the high definition maps. So this sounds like a nightmare for city officials and autonomy providers doing this at any kind of scale. So you could probably perfect one area, one city, but then what's the point of that? We're talking about 10 million robo-taxis and then beyond, you know, is what we're talking about with Tesla's approach in that slide I did by 2030, for example. Transferability, LiDAR does not allow for object detection and recognition. LiDAR can recognize code signs, pedestrians, or an unleashed dog wandering onto the road. Okay, so these drawbacks are documented, so why is Tesla the only manufacturer to focus on computer vision instead of LiDAR? And they basically give three answers: sunken costs, fallacy, first principles thinking, and Tesla's data snowball that others do not have. So the sunken cost is basically these LiDAR companies, they all kind of originated at the same time, 2009, 2013. Around 2012 was a major year for neural networks. They started to advance rapidly after that. There's a nice graph here which shows a competition and the results of it, which shows how accurately different teams with the neural nets they're building could recognize images. And so you go from 2010, there's a huge amount of wrong, a little bit of right, or near perfect, and then that's exponentially increased, or more and more of the teams and their own results are getting more and more perfect, sort of in an exponential line. To 2017 that was, so it's a little bit out of date, this graph. So, but the point is, it's getting exponentially better. So, but companies like Cruise, Waymo, they're suggesting, these guys writing this article, and I think it makes sense. They really went all in for LiDAR back before it was before the advancements really took off with neural nets. And so for them to make up this sort of big pivot, turn 180 degrees toward computer vision, really means that their engineering executive teams need to invalidate their own strategy. So they have to really admit that they're wrong, and they spent a bunch of money so far, starting these projects and continuing these projects. So it's hard for them. It becomes harder and harder for them to just give up now on these projects because of that sunken cost. That's the sunken cost fallacy. That means even though maybe the end result's not going to be what you want and you shouldn't do it, you continue to do it because you already spent so much money on that thing. So yeah. that's one reason why they're continuing with LiDAR. Okay, another reason why they're saying is that Tesla's the only one who's sort of doing this computer vision is because they're the one that thinks the clearest in this first principles thinking. And that's really, I've talked about this a lot in some other videos. I love this analyzing things and trying to consider, is this first principle thinking or not? And really, first principle thinking is all about trying to boil something down to arguments that make the most sense, pretty much from a physics standpoint. And yes, this makes sense from a physics standpoint, from the most kind of baseline truth we can identify, or know that this makes sense. And you're not trying to make versus reasoning by analogy would be the alternate, where you basically make an analogy and then use that to project that onto your own rationale or reasoning or your own conclusions. You could make a case that Gary Black's tweet at the start there, if we go back to, I'm just going to flip back in the presentation here briefly to Gary Black's tweet here. He talks about how a supercomputer beat a chess champion, Gary Kasparov, in 1997, but then soon several supercomputers could beat any human. To me, this is reasoning by analogy. It's just one example of many that he's basically saying, hey, guess what? There's this other example: a supercomputer beat a chess champion, and then a few years later, more supercomputers did it. So that means full self-driving, once one person does it, everybody's going to do it. Doesn't mean that that's wrong, but it's not really that's not reasoning by first principles. That's reasoning by analogy right there. Great example. It's interesting. This is the reason why other companies are probably stuck with LiDAR, is because solving autonomy with computer vision is actually more difficult than utilizing LIDAR. I mean, I remember even 10 years ago, Google had little pod cars driving around their Google campus, examples of it. And it was very exciting, and they were, you know, autonomous vehicles driving around, but they would have been running on LIDAR. So it's a way you can build a model quickly, and you can look like you know what you're doing, kind of like the student who's got all the right answers for the test, but it actually, you have all the right answers for the test, but you actually don't, if you try to go beyond just the test grounds or beyond anything beyond that sort of brittle framework of that, it quickly breaks down. So another example is Mobileye, and it's gone with this computer vision and LiDAR augmented approach. So it has a bit of both, and they're asking the question, why did Tesla go 100% in computer vision, but and Mobileye doesn't? It's because Mobileye, in their opinion, and other startup companies, they lack Tesla's snowball effect. So they go into more detail on their snowball effect here. And the snowball effect just means Tesla has a ton of data. And the more data you have in your neural network, the deeper you can go with your machine learning modeling advantage. And example of this, I remember hearing somebody, I heard this example about neural networks. It's kind of like you can show and how they're different. I guess how they're different from human beings, and maybe how the data is important versus how human beings would learn. So human beings, you can show a picture of a cat to a human being, and then you can actually go, and the human being can basically go anywhere in the world, and after seeing that one cat, can then identify other cats. But a neural network, you kind of like, you almost need to show it 1,000 pictures of cats before it can recognize one cat and know what a cat is. So the more data you have, the deeper you can go with your machine learning modeling advantage. And Tesla, they blow everybody out of the water. It's not even remotely close. For example, Waymo had 20 million miles driven in 2019 of testing miles compared to Tesla's 3 billion. And I know that this difference is only increasing as the rate of, obviously Tesla's vehicle fleet is growing at an exponential rate. So way more data to go deeper and deeper and deeper with their analysis. And it gives some more clarity on this. Like somebody like Waymo, they might be able to develop computer vision models that perform at 90% or even 95% accuracy, but achieving that several nines level performance, 99.99%, kind of, on and on. It's just not feasible with the type of amount of data they have. Their final sort of point here of the article is that Tesla's vertical computer vision approach cannot easily be copied. It's the right approach, but it also can't easily be copied. So let's get into that. They say, they talk a little bit about neural networks. It's not a traditional code in a traditional sense. Does not rely on the traditional conditional if-else construct that you think about with coding, but outputs a probability of certain event occurrences. And then that is fed into these probabilities are fed into traditional code to generate the behavior of the entire system. The system only works as well as a set of inputs that is identical to what it was trained on and runs well on the hardware it was designed to execute on. Okay, so the typical workflow for deploying deep learning models to an edge device, example would be vehicles, is accumulate and label a large set of data. Then you train a large model, and then you use this initial model to train on a set of supervised tasks that have been labeled, for example, stop sign images. Approximate this model to fit on a device. So you allow this to fit on the device or on the vehicle, and then optimize the model to achieve maximum throughput on a given device. So optimize it so it can solve these neural nets as rapidly as possible, and then deploy the model and monitor the feedback to verify online performance. And somebody tweeted a reply to this article that I saw on Twitter, and I thought it gave a good explanation, but I'll just read his tweet because I thought it was good. People confuse Tesla's data advantage. It's not just a lot of data, it's the loop. And I would agree completely with this. It's not just the fact that you have data, but it's Tesla's ability to integrate and learn from the data essentially, and then act on that learning. So this is his loop. He kind of points out, you gather data, you pick the good data and label that data, then you train the neural network, and then you do an over-the-air update, then you measure interventions. That's your feedback loop, and then you gather more data, and based on those feedbacks, you make changes until your interventions from, these are your full self-driving beta testers that are intervening, gets lower and lower and lower. This is the speed of the cycle. And I thought that was a really great way to illustrate it for Tesla. So, and then secondly, they say within each of these steps, Tesla has vertically integrated equipment, processes, and code to maintain their autonomy lead. So they do, again, over-the-air updates. They have a team of specialized data labelers. They have the Dojo supercomputer that's coming to train large neural networks efficiently. They have specialized hardware system that they built for their full self-driving, entirely specialized for it. And then they do shadow testing through silent interface, which is also extremely powerful, that the neural network is still making predictions while humans drive, but those predictions are not used to control the vehicle. So because they have this fleet of ever-growing, larger and larger fleet of Tesla vehicles, they're able to make shadow predictions through that based on what people's actual driving behavior is like. And even if conventional OEMs got all the talent, tools, and everything together, they're still years behind Tesla's computer vision approach. They can't really reverse engineer this black box effects because of all the data transformations that occur. And many OEMs like Volkswagen have decided to outsource autonomy to LIDAR-based systems like Mobileye. And in my opinion, anytime you're trying to work like the stack, this is not a full stack. This is not as vertically integrated. Anytime you're trying to have a partnership where one partner is a Volkswagen, they're trying to partner with somebody else, and they're two separate entities, but they're trying to work together. Sure, they can work together, but they can't work together as well as one vertically integrated company. The more you can bring in-house in any company, in any industry that's vertically integrated and integrated well, you can achieve much bigger things. You can achieve more, become much more profitable. And this could be a whole other video talking about vertical integration, why it's so powerful. So they say, basically they believe people that are against this are wrong. People like Gary Black, they don't believe this are wrong or think it's easily copyable. And this period before why Tesla full self-driving beta release is the last window of uncertainty. And I've kind of mentioned this, that I think until full self-driving, I just mentioned this in this, I called it actually, I called it the window of opportunity in one of my last couple of videos I did. That really right now, and to me, is one of the last times to be buying Tesla shares at the current prices, whether it's $500 a share, $600 a share right now. Because I personally think once full self-driving beta is released and begins to, US wide, and I did another video on this not too long ago, how the step-by-step, how I see full self-driving beta and then full self-driving kind of being unraveled, or rolled out, I guess, US wide and then worldwide. I think which will take years and years to fully do, but once it starts to happen, I think the price of Tesla could start to soar. And this is a really great article. I'm going to link the article down in the description. If you want to check out the full article there, make sure you type in your email on their article as well and subscribe to their newsletter to support these guys. And I want to throw this up last slide once again, because this is such a big deal. I'm projecting, and I think this is actually conservative, it could be like $8-9 trillion market cap by 2030, and that could continue to grow. It sounds ridiculous, but when you look at the strategy they're employing and you look at the competition that's out there, I don't think it's that ridiculous. So that concludes this video. I'd love to hear from you guys what you thought of this video. Please let me know in the comments down below. Let me know what these guys got wrong. Let me know what I got wrong. Let me know what you agree with. Let us all know so we can learn from each other. If you got value out of this video, I encourage you to hit that subscribe button. Hit that thumbs up while you're at it. It really helps me out. Thank you so much for watching. I will see you in my next video. And remember, it's in the bag. Cheers.